3. Chapter 3 is quadratic functions, and we are back into the quadratic functions that we did do in grade 10. So some of this stuff, or a lot of this stuff, will be review. The first one we're going to do is our recall, so I want you to remember our lovely quadratic in vertex form. Okay, you might have used H and K, different letters, same thing. I use P and Q, doesn't really matter. But when it's this nice vertex form, the vertex will be P and Q. The reason why we write the negative there is because it's always the opposite, right? Opposite sign, so P, Q. The domain is anything, any real number works. The range, if it opens up, will be greater than or equal to whatever the Y value is. If it opens down, less than or equal to whatever the Y value is, okay? The equation of the axis of symmetry, so again, when we have the axis of symmetry was always going to be halfway, so at the vertex here, so this is the axis of symmetry, whoops. Okay, so axis of symmetry, and that one was always given an equation, so just remember, it should always be an equation, so I'm going to highlight that word equation of the axis of symmetry. Okay, so that axis of symmetry should always be an equation form, not just 2 or 3. So x equals whatever that number is. If A is positive, so if the number in front is positive, it opens up. If it's negative, it opens down. Right? We know all that stuff. The step pattern, again, I'm not sure if you learned the step pattern, but I like to do the step pattern because it's faster, was always over 1, up 1, over 1, up 3, up 5, up 7, etc. And it's by a multiple of A, which is whatever the number is in front. And again, I'll go over that when we graph it. Okay, so in the example below. It should always be symmetrical. Right? If it's not symmetrical, then something's wrong. Okay, so let's try that. So that's what we need to remember. And now let's do our little checkup, which is state the vertex. So from here, we have from here, it's going to be -2. And then since there's no number here, 0. Right, so the -2 comes from here, it's always opposite, and the 0 because there's no number after. Okay, make sure you put the bracket on. I'm not going to accept anything sloppy, right? So if you don't put the bracket on, it's not a coordinate, right? Then it's just a list of numbers, right? So we want the bracket to say it's a coordinate, not a list of numbers. For this one, the vertex would be, in contrast, that's a -3, so it would be a +3. And here, -5, so it'd be a -5, right? So then here, again, you get that from here and from there. All right. The domain for any parabola, any quadratic function, is going to be x is an element of real. The range depends on if it opens up or down. So what I first do is I look over here and I go, this one here is negative, so it opens down, right? So in my head, I picture down. This one here, I look over here and I say, okay, it opens up, right? And that tells me that because it's negative, it opens down. My range is going to be y is an element of real such that y is less than or equal, opening down, to the y value that I have in my vertex, which is 0. Okay, this next one here, y is an element of real. Okay, and then y is, over here, it's positive, so it's greater than or equal, and you take the y value, -5. Okay. Equation of your axis of symmetry. So again, if I say axis of symmetry, I still want the equation. So whether or not I say it, you have to know that that means its axis of symmetry is not just a number, it's always an equation of, right? So we want to make sure we do the equation of the axis of symmetry. So this is going to be x equals, and it's always going to be symmetrical at the vertex. So if we look here, it's wherever the x value of the vertex is. So x equals -2. That's where your fold line is if you're going to fold the parabola in half. So here, x equals, wherever your vertex is, 3. This we already know, because it was negative, we opens down. And here it's positive, so it opens up. Okay, let's graph it and let's practice the step pattern. So this first one here, it's going to be negative 2, 0. So negative 2, 0 is my vertex. And I know it opens down, and the step pattern is negative 3. So for this one, I go 1, 3, 5. I'm not going to get beyond 1, 3, 5. And I take that and I multiply it by the A value. So for this one, A value is negative 3. So in my head, I go negative 3. So I go times negative 3, or times 3, and just make sure it's heading down, right? So times negative 3. You don't have to show all this work, but I'm just showing you what my brain is thinking. So it's going to be negative 3, negative 9, negative 15, right? So this is for A. This is for the A question. Again, you don't have to show all this, okay? But this is what I'm thinking in my brain when I graph it. So I take my vertex from here, and I go over 1, over 1. It's always over 1. So over 1, down 3. 1, so it's over 1 square, down 3. 1, 2, 3 squares. Then over 1 and down 9 squares. I don't think I'll fit. 1, 2, 3, 4, 5, 6, 7, 8. No, it won't fit. Okay, so just draw as far as you can draw. If you can't fit any more, that's fine. So over 1, down 3. And you just know that that parabola, right, the graph that we're drawing, the parabola is going to be real stretched out vertically. So just don't make sure that this line stays within those two lines here, because it's not going to go touch it. It's way beyond. It's way down here somewhere. So don't go too wide. And it just stays in there somewhere. Put arrows on the end. Okay, I want to see as many points as I can. I do want the arrows, please. Okay, we talked about this before, but arrows mean the graph continues. A point means that it stops, right? We know the difference now for domain and range. Right, so I want arrows on the end. Okay, again, this is reviewing, so then we're going to do the next one. Okay, let's do the next one. And we're going to do the vertex. So this is for B. The vertex is 3, negative 5. 1, 2, 3, 4, 5. So put your vertex there. We know for the step pattern. We've got that 1, 3, 5, and we're going to go times, what's my A value? 2. So we put that here, and again, you don't have to show all this work, but just so you know where I'm thinking. Okay, so that's giving me my new value, so it'll be 2, 6, 10, right? So times 2, times 2, times 2. So from here, okay, I'm going to go over, and it's positive, right? So it's opening up. So over 1, up 2, over 1, up 6. I can fit the 6. So 3, 6, like that. Okay, over 1, up 2, over 1, up 6. Okay? And then can I fit 10? I can't fit 10 more. Okay? So then you just draw it and then keep it within that square. I grab the paper. I have to twist it a bit when I'm drawing it. Okay, as good as you can. Make sure that you've got your dots there. Try not to make it like multiple lines. Like you have to erase and do your best to draw it again. Okay? I don't want like fuzzy graphs. Okay, not multiple lines. Okay. Good. Okay, refreshing our memory from grade 10. We're going to do a next page. It's on the next page. Okay, I'm going to keep the recording going because I think I can do one more example, and then I'll stop it at the end of example 2. So write the equation for each of the quadratic functions. Oh, it should say functions, sorry. Okay, I have a vertex at 2, negative 6, it's opening down, and it's congruent to. The only thing I need to remind you of is this congruent means the A value. Okay? Congruent to means the size, right? The size of the parabola is a times 3. So congruent means that it's times 3, right? The A, but this means it's negative. So opening up and down will give you the positive or negative, but this will give you the actual magnitude, the value. Okay, so you have to look at the two things. Don't just say that this is size 3, congruent to size 3, so I'm going to take the positive. It says here it's opening down, right? So that's like saying if I'm wearing a size 3 shirt, if I'm upside down, it's still size 3, but this one's opening down. So you're upside down wearing that shirt. Okay, so these are two separate. This is size, and this is which way it's opening. So these are two separate things. Okay, everyone always goes, but it's positive, but it said opening down. Okay, so these are two separate transformations. Okay, so then when we're writing our equation, y equals or f of x, it's up to you. A is going to be 3, but look, negative 3. Okay, everyone always forgets that. They go, but it's A is 3. A is the size, but then this opening up or down are separate things. Okay, so just star that. That's separate. Okay, you just always want to take that one, but it's opening down. Then bracket x. If the vertex is at 2, it's minus 2. Please don't forget your squared. I'm going to highlight that. You're so much concentrating on plus, minus, all the other stuff, you forget to square your little graph. Okay, and next year we're going to learn cubes and quartics and stuff, so you have to put it down. Right, we're going to do 3s, 4s, and stuff like that. So we want to remember that. Minus 6, that's it. Okay. If I ask you for standard form, okay, standard form, that is called expanded form. So think of standard. Standard is like what you maybe started with in grade 9, right? You would never have all this. You'd be like, oh my gosh, there's so much going on, so much order of operations and happening. So standard form is when you just have everything expanded out and collected. So if the book says in standard form, if I say standard form, what form is this? Vertex form. That's right. So vertex form here. So this is vertex form. Okay. Standard form is when you expand it out. So let's take this guy and remember to expand it out. Okay, so let's take this. I'm going to go y equals negative 3. When you expand this out, this part squared is x squared. What else? Minus 4x. We're never going to forget that middle term anymore, please. Okay, it's so sad when you do because you're losing that same mark, right? We're never going to lose that mark again. It's from grade 10. We know it's expanded, got the middle term. Then we're going to bring the 3 in. 1, 2, 3, and collect up our like terms. So it'll be negative 3x squared plus 12x minus 12 minus 6. And then we have our two like terms, so don't forget that. So this one and this one are like. And our answer would be negative 3x squared plus 12x minus 18. Is that right? Looks good to me. Okay, so that's standard form. Standard is all expanded out. That's vertex form. Okay. Now, same question. I want you to write the equation, and then I asked for standard again. I described it in a slightly different way. Right? So again, for communication purposes, you got to be able to understand more than one way. I said the range is greater than or equal to 3. The range is greater than or equal to 3. What information am I giving you there? I say the range. Yeah.
The direction.
The direction, yep. So I know it's going to be opening up. Greater than, so it's opening up, so I know it's going to be positive. Anything else?
You know your Q.
Yep, you know your Q. You knew your Y value, right? So that part there, that'll be your Q. Your Q is 3, starting at 3 and heading up. So I got 2 pieces of information from that one statement. I have the axis of symmetry, which is going to give me my P. Right, so that'll get me my P value. So P, right, P is the 4. And it's congruent to, what is this going to give me? If it says congruent to this, that gives me only the A is 2. Does that make sense? Don't grab the negative. I know everyone grabs that negative. I'm showing you the tricks. So I'm showing you the tricks that I give you here. So you go, I will never make that mistake. So when I show you the trick, look, I gave you a negative. You feel like grabbing that negative, but remember, congruent means only the size, and this up or down means the positive or negative. They're two separate transformations, right? This is a vertical stretch. This is a vertical reflection. They're two separate transformations when we did our transformations. Okay, so they're not one statement. It's two separate. One of them is a stretch and the other one's a reflection. Yes? This is a stretch, so times 2 is a stretch, and the neg up and down, plus and minus, would be the reflection. Right? So that's saying it's a stretch. Congruent means it's a stretch by a factor of 2. Okay? But this saying up means that it's not reflected at all. It's still opening up. So there's no reflection. Right? So they're two separate statements. Okay? All right, so then we're going to write our equation. So y equals, or f of x equals, a is 2, and we're leaving it positive, right? Don't lose that mark for putting a negative, because I'm telling you that's the typical mistake. Okay, so it's positive 2 because it opens up. Bracket, x, p is 4, so minus 4. Square it. Do not forget the squared. You're going to kick yourself in the butt if you do forget the squared, because you're concentrating on everything else, you forget to square it. Okay, so squared, it's quadratic, and then q is 3, so plus 3. Did I forget anything? No, good. Okay, and let's do expanded form. So one more time, we are not going to ever make that mistake here, x minus 4 all squared. So it's x squared minus 8x plus 16 plus 3. Okay, and then we're going to get 2x squared minus 16x plus 32 plus 3, and 2x squared minus 16x plus 35, all done. So that's our nice expanded form. Any questions with that?